So guys, now let us try to understand the difference between GLThreads and traditional W-linked list with the help of a diagram. So you can see that the following diagram represents the traditional W-linked list. And as we know that each node in a traditional W-linked list has a left pointer, has a right pointer, as well as has a data member which actually points to the application data. Right? So this is how your traditional W-linked list looks like in the memory. Now contrary to this, the GLThreads looks something like this. Now you can see that in the traditional W-linked list, your application data is present elsewhere in the memory. And the node of your W-linked list actually stores the address of your application data. So let us suppose that for this application data, the address is A, then the node of a W-linked list which actually points to this application data will hold the address A in the data member of a node of a W-linked list. Whereas in case of glue-based W-linked list, there is no such thing. So first of all, for the rest of the course, to avoid any confusion, I will going to call glue-based W-linked list as GLThreads, right? And I will going to call a node of a glue-based W-linked list as GL node, right? So it will avoid any confusion whether I am referring to a node of a traditional W-linked list or I am referring to a node of a GLThread. Now you can see in the second diagram actually represents a GLThread which is holding application data. Now we already know that GL nodes doesn't have void star data member to point to the application data. So you can see that this actually represents the GL node and it has only left and right member which points to the left and right node of a GLThread. So you can see that the application data is actually tightly glued with the GL node. So think of it like an application data has some sticky gum using which it can stick itself to any W-linked list. Now here W-linked list means GLThreads. And this sticky gum is nothing but it is a node of a GLThread, that is GL node. So you can see that this structure represents some application data which your application is using. And one of the member of this structure is actually GL node. So this member, to be precisely saying that this member is nothing but it is GLThread node. And let us call this member as glue, because using this GLThread node, this application data will going to stick itself to a GLThread. Now we will see in the remaining portion of this course that how GLThreads work, how application data is glued to a GLThread, and how do you iterate over a GLThread, and how do you access the application data while iterating over a GLThread. Now at least you must be getting some high level idea that what is the significance of the word glue in glue-based W-linked list. So here glue means that something using which you can stick an object onto other object. Here one object is an application data and this application data has GL node as one of its member. This GL node is nothing but it is a glue, and using this glue, this application data can actually stick itself to a GLThread. So you can see that this application data, this is a member of application data which is nothing but a glue. And using this glue, this application data has stick itself to a GLThread. Now as we proceed into this course, I will show you how to implement GLThreads and how to perform various operations which you typically perform on a traditional W-linked list on GLThreads.